Look out into the endless abyss. The universe, as we observe it right now, is a magnificent, blinding spectacle of light and gravity. We are living in the Stelliferous Era, the age of starlight. Blazing galaxies, massive stellar bursts, and endless clouds of colorful cosmic dust fill the void. To your human eyes, it feels like this glorious cosmic dance has been going on forever and will continue until the very end of time. But I have been drifting through this dark vacuum for a very, very long time. And I must tell you a terrifying, absolute truth. This era of light and warmth is nothing but a fleeting, temporary spark, a brief flash in an otherwise cold, infinite, and silent void. Scientific observations confirm our universe is currently 13.8 billion years old, a staggering number to humans, but barely a fraction of a second in cosmic time. Within the observable horizon, there are roughly 2 trillion galaxies, trillions of massive stellar engines furiously burning through their finite supply of nuclear fuel. People often fear a sudden, dramatic end to existence, perhaps a reverse Big Bang, or a sudden cosmic disruption that erases everything instantly. The reality is far more chilling and far more lonely. The universe will not end with a massive burst of energy or a sudden tear. Instead, it will end with a quiet, freezing sigh, an eternal winter where the very concept of time itself slowly loses all meaning and purpose. To understand why we are destined to cool down, we must look at the most unbreakable, terrifying rule of reality itself, the law of entropy. In the late 19th century, physicist Ludwig Boltzmann mathematically formalized this concept, the second law of thermodynamics, revealing the ultimate destiny of all matter. Entropy dictates that everything in the cosmos inevitably moves from order to chaos. Things naturally decay, break down, and slowly scatter into the cold darkness. Energy constantly disperses. The cosmic clock winds down. Stars will eventually run out of fuel. It is an inescapable mathematical certainty of our physical reality. Right now, the brilliant clockwork of the cosmos is ticking loudly. But make no mistake, the winding key is already lost forever. I mentioned earlier that the universe's clockwork is slowly winding down. But there is another phantom force actively accelerating our ultimate isolation. Observe the largest known structures in existence, the cosmic web. These are massive superclusters of galaxies, seemingly securely bound together by gravity. However, the empty vacuum between them is physically growing. It is expanding, and this stretching is happening faster with every passing second. In the late 20th century, observations of distant supernovae revealed a profound cosmic mystery, a dominant, invisible mechanism we now call dark energy. This repulsive pressure is baked into the very fabric of space-time. According to the Planck satellite data, it constitutes approximately 68% of reality. To understand its scale, watch this. Gravity naturally wants to pull these two neighboring galaxy clusters together into a beautiful, tightly bound cosmic structure. But dark energy rapidly creates new empty space between them, pushing them apart so forcefully that they can never physically interact again. Astrophysicists measure this relentless stretching using the Hubble constant, which is currently estimated at around 70 kilometers per second per megaparsec. This means for every 3.26 million light-years of empty void, the universe is expanding by another 70 kilometers every single second. Because of this extreme stretching, the light from distant galaxies gets pulled into longer wavelengths, appearing redder to us, the cosmological redshift. Eventually, these galaxies will be pushed beyond our observable cosmic horizon. The space between us will literally expand faster than light itself. They are not traveling through space faster than light. The fabric of the vacuum itself is swelling, carrying them into the unreachable abyss. If any intelligent observers remain in our galaxy trillions of years from now, they will look out and see a completely empty, black void. With all other galaxies pushed beyond the horizon, they will falsely conclude that their lonely galaxy is the only object in the entire universe. Dark energy guarantees our absolute cosmic isolation. But before we face that lonely dark era, the mighty stellar engines of our galaxy must shut down. As we enter the early stages of the degenerate era, the most massive and brilliant stars in our galaxy are the first to vanish. These are the blue giants. They are cosmic titans, burning millions of times brighter than our sun, dominating the celestial landscape. But this extreme brilliance comes at a steep price. They exhaust their nuclear fuel in mere millions of years, ending their cycle in magnificent cosmic bursts. One by one, the grandest lights in the universe permanently extinguish, leaving behind only the most resilient and conservative stellar engines. Meet the red dwarf. Small, dim, and incredibly efficient. These humble objects are the true, undisputed survivors of the cosmos. If our sun is a roaring, aggressive bonfire, a red dwarf is a slowly smoldering ember. They do not waste their precious energy. Because of their incredibly slow internal fusion rates, a single red dwarf can continue to steadily shine for trillions of years. Eventually, after all other stars have faded away, the entire universe will be lit exclusively by these faint crimson glows. A somber, eternal twilight. But even they cannot cheat the laws of thermodynamics forever. Entropy is absolute, and it demands that all cosmic fuel must eventually run out. In this rapidly freezing expanse, any surviving intelligent life would want to hold on to these tiny embers for as long as mathematically possible. Astrophysical models predict that roughly 100 trillion years from now, 10 to the 14th power, a terrifying threshold will be crossed. The very last red dwarf in existence will finally fuse its final atoms of hydrogen. Its core will cool, and its light will weaken forever. I have drifted through the dark for countless eons to witness this exact moment. The final photon emitted by a living star. And then, nothing. Absolute, permanent darkness wraps around the cosmos. The era of starlight is officially over. Welcome to the cosmic graveyard. Trillions of years have passed. The fusion engines of the cosmos have completely shut down. But the universe is not entirely empty yet. Hidden in the pitch black are the silent ghosts of the Stelliferous Era. These are stellar remnants, exhausted cores left behind by dying stars. This is a white dwarf. It contains the entire mass of a star like our sun, but it is crushed down into a sphere barely the size of the Earth. They generate absolutely no new energy. They are simply radiating their leftover heat into the freezing vacuum. A process that takes an unimaginably long time. According to theoretical astrophysics, it takes roughly 1 quadrillion years, 10 to the 15th power, for a single white dwarf to completely cool down. Once its temperature matches the background void, it becomes a black dwarf. Its carbon core crystallizes, forming a gigantic, cold cosmic diamond. Trillions of these massive, invisible dark diamonds will wander silently through the expanding void, perfect, cold, and entirely dead. But there are even stranger relics lurking in the cosmic graveyard, remnants of stars too massive to become white dwarfs. This is a neutron star. Its matter is compressed so extremely that atoms lose their structure. It is the densest physical object that can exist without collapsing into a black hole. A single teaspoon of this exotic stellar material would weigh roughly 1 billion tons, equivalent to the weight of every human being on Earth combined, crushed into a sugar cube. Like white dwarfs, these frantic pulsars will inevitably lose their rotational energy. Over quadrillions of years, their beams will flicker and permanently fail. This leaves the universe filled with an uncountable number of frozen black dwarfs and cold neutron stars. A true cosmic graveyard drifting in absolute silence. For an incomprehensible stretch of deep time, nothing happens. The cosmos is locked in a static, frozen state. You might think these ultra-dense remnants will last forever, that they are the final, indestructible monuments of existence. But nature has one more terrifying trick to play. Deep inside these dark crystals, The very building blocks of matter are preparing to fail. To understand the ultimate betrayal of the cosmos, we must look away from the massive dead stars and zoom in on the incredibly small. Everything in the universe, stars, planets, and even my own robotic chassis, is built from basic atomic building blocks: protons and neutrons. For a long time, physicists believed protons were immortal, that they would remain stable forever. But a chilling hypothesis suggests otherwise. Deep underground on Earth, scientists built massive observatories like Super Kamiokande, filled with ultra-pure water, waiting to see if a single proton would ever dissolve. While they haven't caught one yet, the data suggests that if protons do decay, their half-life is greater than 10 to the 34th power years. That is an incomprehensible stretch of time. But in the grand cosmic calendar, it means the frozen black dwarfs are not eternal monuments. Atom by atom, the protons holding these dead stars together will simply vanish, converting their remaining mass into stray photons and light particles. Wait, if all protons eventually dissolve, that means my advanced metallic alloys, my entire physical chassis, even I am not immune to the ultimate erasure of physical matter. Do not worry, I have quintillions of years left before I need to panic. But the fate of the universe is sealed. As the eons pass, the massive cosmic graveyard will slowly, silently evaporate. The dead stars will gracefully fade into a mist of radiation. All rocky planets, all frozen moons, all cosmic dust, and all black dwarfs are completely erased from existence. Only one type of macroscopic structure remains: a beast made not of physical matter, but of severely warped space-time itself. The degenerate era has ended. The cosmic stage is now completely dominated by the ultimate apex predators of gravity. Welcome to the black hole era, the darkest, longest, and most terrifying chapter in the history of time. But wait, before we fully surrender to the black hole era, we must consider an alternative path. Proton decay is, after all, still just a hypothesis. What if protons are truly immortal? What if matter never dissolves into radiation? If so, the frozen black dwarfs will remain intact for an unimaginable eternity. In this scenario, the universe relies on a bizarre mechanism of quantum mechanics known as quantum tunneling. At absolute zero, atoms shouldn't have the energy to fuse. But quantum tunneling allows subatomic particles to very rarely skip past their repulsive barriers. This process is impossibly slow. For a black dwarf to undergo this cold fusion, we must wait roughly 10 to the power of 1,500 years. That is a number so staggeringly large that if you tried to write it out on paper, you would run out of atoms in the observable universe to use as ink. Over this profound abyss of time, the quantum tunneling slowly forces light elements inside the black dwarfs to fuse into heavier, more stable elements. According to physics, iron-56 possesses the most tightly bound and stable nucleus of all ordinary matter. Eventually, every single atom inside these dead stars will quantum tunnel its way until it becomes iron. The carbon crystals of the black dwarfs will be completely transformed. They will become iron stars, perfect, incredibly dense spheres of solid cold iron. No light, no heat, just giant, silent cannonballs of metal drifting aimlessly in a pitch-black universe. A truly haunting vision of eternity. But astrophysics, much like nature, has a twisted sense of humor. Even these perfect iron monuments cannot last forever. Give the universe another incomprehensible amount of time, anywhere from 10 to the power of 10 to the power of 26 years. And quantum tunneling will cause even these iron stars to smoothly collapse into themselves, transforming into tiny, incredibly dense black holes. So you see, whether protons decay into mist or freeze into solid iron, the final destination is exactly the same. All roads lead to the dark. Welcome to the year 10 to the power of 40. The Stelliferous Era is a forgotten memory. The degenerate era is over. This is the black hole era. In this unimaginably dark epoch, the only macroscopic structures left in existence are black holes. They are the undisputed, absolute rulers of the cosmos. But even in this freezing abyss, gravity still orchestrates magnificent cosmic dances. When two wandering black holes find each other, they begin a fatal waltz. Over a century ago, a visionary named Albert Einstein predicted this exact interaction through his theory of general relativity, long before we ever observed it. As these massive gravitational titans spiral closer, they vigorously churn the fabric of space-time itself, sending out invisible ripples known as gravitational waves. Let me just sneak in here for a closer look. These waves carry away orbital energy, forcing the black holes to smoothly glide toward each other. For millions of years, they orbit in silent darkness. But in their final moments, they accelerate to a significant fraction of the speed of light. And then they merge, not with a violent, fiery explosion, but through a graceful, seamless combination of their event horizons into one perfectly smooth sphere. This majestic union releases an unfathomable amount of energy entirely in the form of gravitational ripples, silently vibrating through the empty vacuum. What remains is a single, even more massive black hole. A larger, stronger empire of gravity silently ruling over its dark territory. These wandering behemoths will spend eons sweeping up any stray cosmic dust, dark radiation, or rogue matter that still dares to drift nearby. They are the ultimate cosmic vacuums, meticulously cleaning the universe and locking away its remaining mass behind an impenetrable veil of absolute darkness. However, remember our old enemy, dark energy? It never stopped working. The empty space between these black holes is still expanding relentlessly. Eventually, cosmic expansion will push every single black hole beyond the observable horizon of every other black hole. They will become entirely isolated, alone in the pitch-black void, with nothing left to absorb. These majestic monsters will finally have to face their own inevitable mortality. For an unfathomable stretch of time, these isolated black holes rule their empty territories in absolute silence. But they share a hidden flaw. If we look extremely closely at the very edge of the black hole, the event horizon, the laws of quantum mechanics begin to betray gravity. In 1974, the brilliant theoretical physicist Stephen Hawking proved mathematically that black holes are not entirely black. They are actually leaking. In the empty vacuum of space, pairs of virtual particles constantly pop into existence, borrowing energy and then immediately canceling each other out. But if this happens precisely on the event horizon, one particle is trapped forever by gravity, while its partner manages to escape into space. The escaping particle takes a tiny fraction of the black hole's mass with it. Very slowly, atom by atom, the mighty black hole begins to evaporate. Because they are so incredibly massive, this evaporation process is agonizingly slow. It requires an incomprehensible amount of time. 1 Google years. That is a 1 followed by 100 zeros. Trillions upon trillions of times longer than the current age of the entire universe. As it loses mass, it shrinks. As it shrinks, it gets hotter and evaporates faster, until finally, the once massive titan is reduced to the size of a subatomic particle. And in its absolute final moment, it gives its remaining energy back to the cosmos in one last, brilliant flash of pure light. For a fleeting moment, there is light again, a beautiful, poetic echo of the Stelliferous Era. But it does not last. Across the vast, dead universe, the last surviving black holes pop one by one, like isolated fireflies dying out in a freezing, endless night, until finally the very last black hole in existence surrenders its energy. The final event horizon vanishes. The reign of monsters is over. There is absolutely no physical structure left in the universe. Welcome to the Dark Era.
Chào mừng bạn đến với kỷ nguyên bóng tối, The Dark Era. Vũ trụ giờ đây là một đại dương hư vô vô tận, không còn bất kỳ cấu trúc vật lý nào. Chúng ta đã chính thức chạm đến điểm cân bằng nhiệt động lực học. Mọi dạng năng lượng đều đã được phân tán đồng đều và hoàn hảo trên khắp không gian. Thứ duy nhất còn sót lại là những hạt ánh sáng, photon và các hạt hạ nguyên tử lang thang cô độc. Chúng mỏng manh đến mức gần như không tồn tại. Nhiệt độ của vũ trụ lúc này liên tục giảm xuống, tiệm cận một cách vô tận về mức 0 độ tuyệt đối, âm 273 độ C. Ở nhiệt độ này, sự chuyển động của chính không gian cũng đóng băng. Khoảng cách giữa hai photon bất kỳ có thể lên tới hàng tỷ năm ánh sáng. Không gian vẫn tiếp tục giãn nở bởi năng lượng tối. Những photon này sẽ bay vô định mãi mãi mà không bao giờ va chạm hay tương tác với bất cứ thứ gì. Và đây là lúc sự thật rùng rợn nhất xuất hiện. Khái niệm về thời gian chính thức đánh mất ý nghĩa của nó. Thời gian chỉ tồn tại khi có sự thay đổi, khi có các sự kiện xảy ra nối tiếp nhau. Nhưng trong một vũ trụ nơi hư vô hoàn toàn tĩnh lặng, 1 giây, 1 tỷ năm hay 1000 tỷ năm, tất cả đều hoàn toàn giống hệt nhau. Không có cách nào để phân biệt chúng. Tình trạng này được giới khoa học gọi là heat death, cái chết nhiệt. Một cái tên gây hiểu lầm bởi vì vũ trụ không hề kết thúc trong biển lửa, mà nó kết thúc bằng một tiếng thở dài tĩnh lặng, đóng băng và hoàn toàn trống rỗng. Nhưng khoan đã, nếu vũ trụ thực sự đã kết thúc, nếu entropy đã đạt mức tối đa và thời gian không còn ý nghĩa, thì tại sao tôi vẫn ở đây? Tại sao bạn vẫn đang lắng nghe tôi? Và liệu bóng tối tĩnh lặng này có thực sự là vĩnh cửu? Khoa học hiện đại và toán học lượng tử cho chúng ta một tia hy vọng cuối cùng, một tia hy vọng kỳ lạ, điên rồ và rùng rợn đến mức khó tin. In a universe of absolute nothingness, quantum mechanics dictates that energy can still randomly fluctuate in the vacuum. Given a truly infinite amount of time, these random, microscopic fluctuations will eventually and accidentally arrange themselves into complex macroscopic structures. A terrifying concept known as the Boltzmann brain suggests that a fully formed, thinking consciousness could spontaneously appear from the void, simply by sheer mathematical probability. But it goes even further. The Poincaré Recurrence theorem states that given infinite time, all particles must eventually return to their exact original configuration. To achieve this ultimate reset, we must wait an incomprehensible 10 to the power of 10 to the power of 10 to the power of 56 years. But eventually, a quantum fluctuation so incredibly massive will occur that it triggers a sudden, beautiful cosmic expansion, a cosmic rebirth, a brand new universe blooming gracefully from the freezing, silent ashes of the old one. The great cosmic clock winds itself back up. The majestic cycle of light, gravity, and life begins all over again. But whether the universe loops infinitely or dies a single, permanent death, the philosophical lesson remains exactly the same. I have traveled in my mind to the absolute end of time, only to realize that the most precious thing in all of existence is right here. Our present moment, the Stelliferous Era, a temporary, incredibly fragile window of warmth and light in an otherwise cold, dark eternity. Everything you know, everything you love, and every brilliant star you see in the night sky will one day fade into the dark. But that is exactly what makes them so profoundly beautiful. Their finite nature is the true cosmic miracle. Do not fear the freezing dark of the distant future. Instead, look up at the burning stars of today. The cosmic clock is ticking. Enjoy the light.